Manager for the FlexiForce division here at Tekscan. For those of you seeking to measure, analyze, and verify force on individual points of contact, the FlexiForce ELF system is your solution.
Utilizing our FlexiForce sensor technology and a user-friendly software program, the ELF is used by engineers, researchers, and scholars to obtain force feedback from between nearly any two surfaces. In this video, I'm going to show you how quick and easy it is to use the ELF to collect force feedback for your project. So let's get started. The FlexiForce Economical Load and Force Measurement System, or as we call it, the ELF system, is a cost-effective, turnkey force measurement tool used in a wide range of test and measurement applications. The system comes standard with analog to digital electronics housed in a USB handle, 3 FlexiForce B201 sensors, each with their own designated force range, and a simple software program. A standard ELF system offers a sampling rate up to 200 Hz, while a high-speed ELF system can record measurements as fast as 6,000 Hz. Users may also purchase up to 15 additional handles to measure multiple points at a time. We also offer a wireless option called the ELF system, which includes a battery-operated Wi-Fi transmitter with the ability to broadcast force feedback up to 65 meters from a receiver. While the ELF system comes with B201 sensors, you can use the ELF system with almost any pinned FlexiForce standard sensor via the ELF adapter tab, which is sold separately. And here on the screen, you're seeing the ELF software that's included with the ELF system. So what we'll go ahead now and do is get ready to take a measurement. So the first thing we want to do is ready our hardware. So here we have the ELF handle that comes with the system and a B201 sensor. To load the sensor into the handle, you simply press down on the blue button of the handle, slide in the sensor, release the blue button, and as you can see, the misaligned text that was near the serial number on the software interface has disappeared, indicating that the sensor is properly loaded in the handle. And now we're ready to load our sensor into our calibration fixture. So the sensor has been loaded in our calibration fixture. Before we can calibrate, we want to adjust the sensitivity. Sensitivity adjustment ensures that the dynamic range of the electronics are going to be properly aligned with the dynamic range of your force for the application. So in this case, our maximum load is going to be about 5 pounds. And generally what I recommend is setting your sensitivity so that you're getting about 80 to 85% output here on your real-time display at your maximum expected load. So we'll go ahead and apply 5 pounds to the sensor. And at 5 pounds, you're seeing that we're getting about 35% output. Again, if we were to continue to calibration or right to measurement this way, our lower load 1 pound and 2 pound range would be in the noise of the electronics. So what we want to do is open up our sensitivity adjustment dialog. And in this case, since the output is lower than we would like, we want to increase the sensitivity. So as you can see, we are aiming for about 80%, 85% at maximum load, and I think that looks pretty good. So to calibrate, we'll first unload the sensor. So we'll go into Tools, Calibrate. In this case, I'm going to opt for the best fit linear. So the best fit linear will essentially draw a linear regression through all of your calibration points. So I'll be doing a 2-point calibration. One point will be at about 2 pounds, and then the second point will be at 5 pounds. So the first thing I'll do is adjust my units to pounds. Input my first calibration force, which is 2. And we'll apply 2 pounds to our sensor. So now we've got about 2 pounds on the sensor, and we will capture this calibration point. And now we will capture our second calibration point of 5 pounds. So we'll input it there, and then we'll change our load to 5 pounds. And there's our 5-pound load, and we'll go ahead and add it. We'll finish. And now you can see that the y-axis on the graph has changed from percent output to our calibrated units of pounds. And as the force applied changes, you can see the output on the screen also changing. Now, just to give you a little bit of insight on the software functionality here, we can display the real-time data as a strip chart. We could also display it as a column, or we can also display it as a number. Thanks for watching. For more information, visit our online store at Tekscan.com.